Hello, Algebra 2ers. Today we're going to be talking about basic polynomial vocab, which should be review from Algebra 1. So this is all old stuff in your brain. So it's nothing new to your brain. It should have been something that you learned in Algebra 1. So what you're going to need today is your notebook, your foldable notes, and a pen or pencil, and especially your listening ears. And actually, if you really don't want to, you don't need a pen or a pencil. You can just follow along and listen and remember all of this prior knowledge about polynomials. But if you want to write along with what I'm writing and annotating, you absolutely can. But really, you don't need a pen or a pencil. What's most important is that we need our listening ears for this video. Your foldable notes should look like this. It's just a half sheet of paper that you'll glue into your notebook. And there's a part that we're going to talk about, like the definition, characteristics, example, non-example. Then there's ways that we can classify polynomials. And then we have operations with polynomials like adding, subtracting, and multiplying. And we're going to dive into these three sections a little more so in this video. First, what is the definition of a polynomial? The definition says an expression that can have constants, variables, and exponents, but no division by a variable, only whole number exponents. Characteristics of polynomials, they're named by their degree or number of terms, and the degree is also known as the largest exponent on the variable. So an example of a polynomial would be this expression right here. We have 3x to the fourth minus x to the second, or x squared, plus 3x minus 10. So remember when we first learned in Algebra 1 that this is called a expression. So a polynomial is also known or can be called as a algebraic expression. So remember, it's things that has constant numbers. So like the negative 10 would be a constant number. Variables, so that would be my x that's involved here. And exponents, which in this example would be like a 2 and a 4. And then it also says no division by variables. So something that would not be division by a variable would be something like this. So 2 over x is not a polynomial. And then only whole number exponents. So this one is not an example because we're saying it's only whole number exponents, and this is not an example because it's only whole number exponents. So even though all of these examples are expressions, only this example is a polynomial. Okay, so we're going to be looking at the polynomial examples in this middle column, and then from there we're classifying them by degree and we're classifying them by the number of terms. So for this example, 6, it's just a constant, which means that the degree is 0. So what we mean by that is we're saying 6 can also be written as 6 times x to the 0, because x to the 0 is the same thing as 1. So our degree on our exponent is 0. And then because 6 is just one term, then if we look over under our number of terms, then because it only has one term, it's called a monomial. Mono meaning one, so monomial. Okay, let's look at the next example, which is x plus 3. So it's a linear degree, or named linear degree, because our degree number of our exponent is only 1. Whenever we see a variable that has no exponent, we can assume that that exponent is 1. So if that happens, then our degree name is linear. And then numbers of terms are, how we figure out the numbers of terms is by counting how many things are being separated from this plus sign. So because we have x and then a plus sign, like separating our expression, and then a 3, so we have an x, so we have x plus 3. So this is one term, two terms. So because we have two terms, that means that it's a binomial. Next example is 3x squared. So my degree is that little 2 exponent, which tells me that the name of the degree is a quadratic. And this example, 3x squared, only has one term, so then we would call it a monomial. Looking on to 2x cubed, so if we look at 2x cubed minus 5x squared minus 2x, that example has a degree of 3, which means that we would call it a cubic by the degree. And it also has 1, 2, 3 terms, so we call that a trinomial. Okay, let's look at the next example. So we have, in this example, x to the fourth plus x squared. So we have the highest exponent, or the degree, is 4. When we call that, what we call the degree of 4 is quartic, and we only have 1, 2 terms, so that means that I have a binomial for the number of terms. And last but not least, let's look at this bottom example. We have negative 2x to the fifth plus 3x squared minus x plus 4. So my degree on this polynomial is 5, which means that it's quintic in name. And then we have 1, 2, 3, 4 numbers, or 4 terms. So that means that the number of terms would be 4. And then any polynomial that has 4 terms or more is just titled polynomial, meaning many. So as soon as it has 4 or 5 or 6 or 7 or 8 or 9 terms, we just classify that as a polynomial. We don't say bi, tri, or mono. All right, so now that we know what a polynomial is and we know how to classify polynomials, we also should have, in our previous math classes, done what we call operations on polynomials, or we can add polynomials, subtract polynomials, or multiply polynomials. So when we add polynomials, it's something you're super used to. We're just combining or adding like terms. So if I have a negative 4x squared, then I can combine that with the 6x squared in my second polynomial. So negative 4 plus 6 gives me in my answer a 2x squared. Then then we know we can look for x variables that are in common. Well, we have a negative 5x in the right-hand side polynomial, or in the second set of parentheses, and we don't have an x term in the first set of parentheses, or the left polynomial. So that means that I can't combine negative 5x with anything, so that just stays as it is. And then last but not least, we can combine the constant numbers, negative 10 plus 4, because those are like terms, and a negative 10 plus 4 gives me a negative 6. So there was no work that you had to do for this one because I already showed you the answer, but that's how the answer is found, is by combining or adding like terms, which is what we've been doing all year. So that shouldn't be any new information to you. So just like adding, we already did adding, we can subtract like terms. And so what most people do is they distribute and then combine like terms. So what we mean by that is we need to distribute that negative 3. So negative times 3x gives me a negative 3x. A negative times 3 gives me a negative 3. And then from here, we can add like terms. Well, x squared doesn't have anything else that can be combined together, so we're going to just put that in our answer. Let's look for x terms. We have a 5x minus 3x. 5 minus 3 is 2x. That's how we got that one in our answer. And then we have 2 minus 3 for a negative 1. So we added or combined the constants together. So my final answer is x squared plus 2x minus 1. So that would be subtracting polynomials. Last but not least, multiplying polynomials. So this is something that we've already done when we were factoring and when we were working in that unit. So it's multiplying is the opposite of factoring, or it's just distributing. So we just need to distribute the x squared to both things in parentheses, so x squared times x gets me to this x cubed. X squared times a negative 5 gets me to this negative 5x squared. Let me change colors here. 3x times x gets me to 3x squared. 3x times a negative 5 gets me to negative 15x. And then last, we always check if there's anything that can be combined. And sure enough, we have 2x squareds in the middle here, negative 5x squared plus 3x squared, which changes to a negative 2x squared. So multiplying polynomials is exactly what we've done in the past when we multiply expressions. We just have to make sure that we're distributing everything that we need to distribute. So I want to thank you all for taking such good notes. If you want to highlight or circle or star all the stuff that I was doing with my annotations with my colored pen, feel free to go back in the video and do so. But if you don't want to, that's perfectly fine. I just want you to get these half sheets glued into your notebook so that when I check, I know that you watched the video. And actually, if you're listening to the video, let's write a magic word on the top of your foldable. So if you go to the top of your half sheet of the foldable in the top right hand corner, let's write the word unicorn. So that way I know that you listened to this video in full length. So if you actually listen to this video, all 7 slides of it, in the right hand corner of your foldable, write the word unicorn, and that's how I'll grade your notes. I want to thank you all for taking such good notes. I'll see you soon.